issues, some little details that you weren't sure how to handle. So let's talk about what those are. So first of all, in your first box plot, the median did end up having to be an average. At that point, some people were not sure how to do the quartiles because they did not know if they use this set as the data to get the quartile from. Yes, you use the 3.8. So then you will, do your quartiles that way. So there's your Q1. Okay? And the same thing here. Because see, these aren't the median. Those are the numbers just next to the median. So then your quartile here ended up being your 12.2. All right. Now, with that being said, we have the range is 14.1. IQR is Q3 minus Q1, so that was 11.6. Okay. You have to basically have the formula for outliers memorized. Now, I'm not one to just say you have to just memorize this random thing. I want to kind of put it into context as something that you can remember in an easier way, and here's the way. The outlier fence is 1.5 IQRs outside of the box. So that's what I have written here. The outlier fences are 1.5 IQRs outside of the box. And if that's kind of like the translation of what the formulas are doing. So then you would just take Q1, which is the edge of the box, and subtract 1.5 IQRs. Or you would take Q3 and add 1.5 IQRs. So this is not just a random formula to memorize. We are putting the fences 1.5 IQRs away from the middle 50% of the data. Okay. So in this case, the lower fence ended up being at a negative 16.8, of which is way out there to the edge because our lowest piece of data is 0.1. So we have no lower outliers, and then I just put my whisker to that 0.1. Okay, and so then for the upper fence, it's at 29.6, and so it's way out here to the right, so it's off the chart as well. So we do not have any upper outliers, so I just put this at the largest part of the data, and there it is. Okay, questions on that? So this one ended up having an outlier. I actually messed up myself, and so it's fixed here. I had forgot to put 190 in. The median is 182, and there's your Q1 and your Q3. Your IQR is 54. So let's do the fences. So for the lower fence, it's this Q1 minus 1.5 IQRs. That puts you way down here somewhere at 66. There's no data lower than 66, so you just go to the lowest piece. Your whisker goes out to the 111. Okay. Now, let's talk upper fence, because there is an outlier, so let's make sure we address the details of it correctly. The upper fence, which is 1.5 IQRs above Q3, is at 282. So, just, FYI, in my data, there's my data, the fence is located here. So that's the upper fence. So I know that this value 439 is then what? It's not within a whisker range. It's an outlier. So since it is an outlier, then I put it way out here and I labeled it 439. So here's kind of where that 282 is. Okay. The next little detail that kind of gets confusing is, what does my whisker go to? The question is, does my whisker go out to the fence since I have something way out there? And the answer to that is no. The whisker goes to the next piece of data that you have inside of the fence. And the next piece of data, okay, let's look back up here. The next piece of data inside the fence is that 209. So that's why that upper little whisker only goes to that 209. Ta-da! Okay, any other questions or little details I missed on that? Okay, Now, you are having a test next Thursday, just FYI, that covers your chapters 2 and 3 information you quizzed on yesterday. I know I won't have those back to you until Monday. And I will tell you that stuff from chapters 4 and 5 is this kind of thing. It's constructing items, it's basic facts. And so I really am not going to have sympathy for you if you don't do your constructions correctly, because they're just like, that's the way you do it, and you've practiced it, and it's like knowing how to add or something. So it's not an interpretive, difficult level of thinking. All right, done with that. The next thing I want us to do is learn how to make a box plot on our calculator. So I want you guys to have a calculator, get your calculator out, or go get one of those calculators. Actually, let me get this started. Hey, I want you to clear your calculator so that if you have any information in there from Algebra 2 or Pre-Cal or whatever it is you've been doing, do your second plus 712. Okay, do your second plus 712. And so here we go. Up at the top of this paper, we have the information that we're going to make a box plot off of. And the first thing we need to do is enter that information into our calculator. And the place where you enter that information is by going to the lists, which is under Stat, and then Edit. So let's get there. Find the Stat button. The Stat button. It's next to the arrows. And then hit Enter. Now put your information into the list. It does not have to be in order. So you don't have to order it yourself. Your calculator will do that for you. Take a second and put that in. I will tell you while you're finishing up typing that stuff in, for some reason, all these kinds of graphs we're doing, the box plots, stem and leaf, the dot plots. And I think I know I touched on this before because Ernie's done these, but other states do this. Texas that has not really ever had you apply it. You may have just like seen it before, but you've never really used it that much. So therefore, I then have to quote unquote waste time from AP Stats teaching you this stuff that a lot of other states learn in middle school. In fact, as I look across other teachers' resources, they frequently have summer assignments doing some of these types of things because it's just a review for them. It's new for you, but a review. Anyway, so here we go. I don't know why I felt like I needed to tell you that. Let's go ahead and graph these. In order to graph, you have to graph it in the stat plot. We rarely use the y equals button in this class because y equals is a function of stuff that happens if you have a perfect relationship. Will we ever have perfect relationship with real world data? No. So most of our place in this class is spent in the stat plot. So that's second y equals. And so we want to go into, yours are probably all off, but we want to go into this first stat plot, hit enter, and turn it on. Okay, and then now let me explain to you what the types of these charts are. Okay, this first little blinking, you see my cursor is blinking on this first little graph. That's your scatter plot, which you've seen before. I don't honestly know what this second picture is of. The third picture is a histogram, of which we will work on tomorrow. The fourth and the fifth picture are both box plots. I'm going to talk to you about which one we are supposed to use. The last one I don't really remember what it is either. But, yeah, a line graph. Okay, so you can see here that this fifth one, the box plot there, is really for more elementary, beginning, introductory box plots because that will not include the outliers. Okay? So we actually use this one. that icon because it is called a modified box plot so that it includes the outlier rules, and we'll show you the outliers. So let's do that. Make sure that you have your modified box plot icon highlighted. Okay, then the XList you are using is L1. If you had your data in a different list, like L2, here's how you go to another list. You press second and then the number. So if I had my data in L2, then I would go second and then number 2. There it is. Okay, L2. Let's say I have my data in second, L5, there it is. So we use lots of data in lots of lists. So let me go back to put the L1 in there. The frequency is used if you have large sets of data sometimes. I'll talk to you about that later. And there's your mark. So we will graph this, not by hitting the graph button, because that will give us a standardized window that doesn't necessarily fit our data. The calculator will fit our data for us by hitting Zoom Stat. That is Zoom number 9. So the Zoom button is there in the middle at the top. And then number 9 is the stat. Yours will look like this if your data is correct in the L1. If you have a typo, then yours could look different. Okay, so Zoom Stat, Zoom 9. Alright, so are we okay? If you have something weird looking, you might go check your list. Okay, here's one of the nice things about this. If you hit the trace button, trace is kind of there above the arrows. If you hit trace, then it will give you some of the values of your information. For example, this piece of data before the outlier is 50. Now, I don't know where the fence is, but the fence, is going to be somewhere in this area here. I don't know where the fence is, but it's somewhere in there. And then this is the piece of data that's just to the inside of the fence. And this down here is the outlier. So if I then go I just arrowed to the left, and it told me that minimum is located at 10. I'm going to arrow back over to the right. That piece is at 50. Watch this. Q1 is 73. I arrow to the right. The median is 81. I'm going to arrow to the right. Q3 is 89. And then finally, the maximum is 100. So it will tell you the 5-number summary. So that's nice. Okay. Questions on what that does for you? Okay. Secondly, I want to teach you how to get the 5-number summary without having to graph it. There are some times you want to graph it and see, because if you want to see how spread out things are. But let's do the 5-number summary just from pushing some other buttons without the graph. So I want you to quit to a clear screen. So I'm going to go second, quit to a clear screen. Okay. So I want my calculator to calculate the data that's in the list, right? Is that what I'm wanting to do? I want to calculate like the median, the Q1, and all that kind of stuff on the list. So where do we kind of start when we have list stuff? The stat button. So stat. Now, instead of editing like you did whenever you put your list in, we are going to be calculating. So I want you to arrow over to calc to the right. All right. This is where you used a lot of things with the functions last year, where you might do linreg to calculate the line, calculate a quadratic progression, or some other things. But we are interested in the first one, which is the one variable stats right there. So I'm going to hit number 1. All right, and you can hit enter at this time, but I do want to tell you, when the calculator is like this, it's defaulting to L1 is the list that it's going to calculate stuff for. If you have your list somewhere else, you need to tell it to, say, calculate that information for L2. Alright, so then you can tell it another list. Otherwise, if there's nothing there, or you put L1 there, it will calculate the statistics for that. So let's hit enter, and then we'll all explain what all this whole bunch of numbers is, and all those symbols and everything. Okay. So the first thing is X bar. X bar is up here at the top. That's your mean. You know that a lot in this class. X bar is the mean. Okay, the thing underneath it looks like a capital E, kind of like a pointed E, right? Okay, that is a Greek letter, capital sigma, and that means sum. It means to add up. So summing the x's. So my total is 1058. So if you have a different sum than I do, then that's you had a typo in your list. Okay. So remember how there's some things, maybe like, I need to make a poster on the wall that's things I'm not supposed to, that we don't want to say or something in here. We say the dependent would be on the wall of words not to say. Proves would be on the word of what the wall of words of not what to say. You know what else? What's that big E mean? What's that? Okay. All right. So don't say, what's that big E mean? It's a capital sigma and it means to sum it up. Okay. Now do ask me if you don't know, but hopefully I'll be better. Okay. A lowercase sigma, a capital sigma looks like this. A lowercase sigma looks like this, and we actually use the lowercase sigma to represent standard deviation in this class, FYI. So we'll get to that actually Monday. All right, let's go back to this. The next three items I'm talking about on Monday, what do you think this n equals 14 means? That's the number of pieces of data that I put into my list. So I put 14 numbers into my list. So that's the size of my sample. Sample size is 14. All right, now watch this. This is the part you've been waiting for. This is going to be what you've been wanting all along. Ta-da! Arrow down, and there's your 5-number summary. Now, it doesn't give you IQR. How would you look at this to get your IQR?
Q3 minus Q1.
Yes, Q3 minus Q1. Okay. Done. That's your calculator lesson for today. So put that away and get the next set of notes out.
Yeah, the question for adjustment.
Sure. Sure. Okay, here we go. Stem and leaf plots and dot plots are what we are learning today. We actually are going to hold off on the histograms. I'm saving those for tomorrow because there's a lot of stuff I want to teach you about those and not just cram it in this day. Stem and leaf plots are another way to visually represent your data. Box plot is a quick representation. A stem and leaf plot is going to give us more specific information because we can tell what every single number is. So let's look at this. Here's a stem and leaf plot. You usually don't see it with all these lines. You actually usually see a stem and leaf plot like this. This on the left is the stems. And then then you'd put your leaves here. A lot of times it doesn't even have commas in between them. Okay, and so on. So this more is the way that you would see this represented. But let me explain to you what this means. Over here are the leaves, and these are the stems. That's the stems are the beginning of the number, and the leaf is the end of the number. You are only allowed to have 1-digit leaves, period. You are only allowed to have 1-digit leaves. So you can't have like 89 over here if it was 0.089. Okay? You only have 1-digit leaves. All right, so let's look at this value. What number does this leaf represent? Good. 0.24. Okay. And then how about this leaf right here, this 2 here, that's what number? 0.82. Very good. 0.82. I'm going from the leaf. All right. So now let me tell you some other qualities about this. you want to make sure that you give all of your numbers the equal amount of space. Okay, so the spacing matters because you're frequently interested in which one had the most data in it. And if you crunch all these together, then it looks like there's not as much, so if I wrote all of these just like in this much space, I have a whole bunch of numbers in here, but it looks like I have the same amount as this row here. So give all of your things equal amount of space, almost kind of like as if you were writing it in graph paper, giving them all same space. All right, let's see here. The benefit to this is that you can easily see all of the individual pieces of data. Other benefit, you can easily do the minimum and maximum. You can easily actually do the median. There's 29 pieces of data here. What piece is going to be what number would be the median? 29 divided by 2 is 24.5, so that means which one's I'm sorry, 14.5, so which one's the median? The what number? The 15th number. The 15th number, so then I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what number is the median? 0.51 is the median. Okay, same, you can use that same technique for the Q1 and the Q3. All right, so let's see. Make sure I got this all. It's good. Stem and leaf plots are good because you have all the original data. You can see each of the individuals. It's easy to find the median, the maximums, the minimums, and all the different other things. A stem and leaf plot is easily changed into a histogram. That's probably the one we're most interested in. We'll talk about that tomorrow, how you do that. But honestly, it's as simple as turning it sideways. So this would be the histogram, where this is the bottom, and these are the bars on the histogram. So see, then you can tell the heights of the bars on the histogram. Anyway, so that's tomorrow. And it's easy to stratify because you can see how you organize the data. All right, here's things that are disadvantages of stem and leaf plots. If you have a whole lot of numbers, you are not going to do a stem and leaf plot. It's too much time, too much mistakes trying to get those things in order. All right. Additionally, if you have really small numbers, like what if I wanted to do numbers that have 1,000th place? Then my stem would have to look like this, and then my 1,000th places would be here. Okay, and then this like gets totally insane. I mean, look at how many of these things I would have to have. Anyway, crazy amount. So small numbers isn't good. So let's make a stem and leaf plot. Here we go. Here's some data of ages of people that attended a track meet. So let's make a stem and leaf plot for it. There we go. Here's my bar to separate my stem and my leaves. I do want to mention you typically want to have, say, 8 to 10 stems. When we look at this data, let's see what the range is. So we've got the lowest number is, looks like it's going to be a 12. The largest number looks like it's going to be, okay. So if I made my numbers, my stems, 1, 2, 3, 4, then I'm going to really probably end up having too much information in a stem, and it's going to not be very user-friendly and usable. So because of that, I want to split each one of those numbers in half. I want a 1 that covers the, and you don't put this down in your thing, but this is going to cover the 10s through the 14s. And then this one is going to cover the 15s to the 19s. So I split 10 to 19 in half. Okay? Then I would have, which ones, what are these going to cover? 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44, 45 to 49. Good. Now let's put in our steps, our leaves. Okay, we do go from least to greatest, so what's the first leaf? A 2. I'm pretty sure there's 2 2s because there's 2 12s. Remember to give each number the equal amount of space. Next, what's next? There's 2 13s. Okay? Looks like there's 2 14s. Alright. 15s. There's 6 15s. They do not go on that same row. Remember, 15 starts on the next row. So, I got 1, 2, 3, 4, 5, 6. Do you see how I lined those up so a number was under a number and they all have equal spacing? Okay, how many 16s? 6. Okay. How many 17s? Right. Man, this is a large bin. Now, my first period did not like that this bin had so many numbers in it. So they thought, and they debated with me and kind of bounced around some ideas of how to make this bin hold less. So here's what they came up with. So let me discuss this and tell you, I just want you to understand why this would not work. They wanted to say, put all the 5s, they wanted to go make this bin 10 to 15, and then this bin 16 to 19. Okay, so what's bad about that? The bins do not include equal amount of values for the stem. This includes 6 numbers, 10s, 11s, 12s, 13s, 14s, and 15s, 6 numbers, and this one only included 16s, 17s, 18s, and 19s, so that only included 4 numbers. Okay, so that was no good. Alright, next, let's finish it out. Okay, where are you going to put that 36? On the second 3, there are no 30s to 34s and no 40s to 44s. So you have a gap. Alright, so from this, you can easily tell a lot about your data. The youngest person at the meet is 12. The oldest person at the meet is... What is the most widely represented age group? 15 to 19 was crazy, whole bunch of people in that group. Okay, we do need to have a key. This class is all about putting context to numbers, to real life to numbers. So here's how you make a key. You write the word key, okay? And then let's draw the little line in between our stem and our leaf, and you pick a stem and leaf. So I'm going to pick the 1 and 2, meaning, then you say what that equals. In context. So what does that number mean? And what is this about? It's about the ages. 12 years old. Important. Context in the key. So a 1 with a 2 means that person was 12 years old. Okay, very good. Next, there are double stem and leaf plots. Okay, double stem and leaf plots are used when you want to compare data. So this is a case that's already drawn out of a teacher who had her 2 different classes in different years, 2009, 2010, and she wanted to compare the distributions of their grades. So this is the double stem and leaf plot that was made. Now, I don't know why we would not have split up the bins anymore. I guess she was okay with having that there. She just used 4 bins, and we typically would maybe want to use more. But let's talk about how to write the key for these. So here we go. Here's our key. Pick a stem. I'm going to pick the stem 7. Now, this number on the left, the first number on the left is a 6, and the number on the right is a 0. So I'm going to explain what that means. What does this left side of this key mean? This is the number 76. It was a grade of 76 in 2009. You could also, write those things here if you wanted to. Okay, what does the right side of the stem mean? Grade of a 70. You see how I'm writing context? In 2010. Okay, very good. So let's make one. This is a comparison of wait times at Starbucks and wait times at a new place in town, new coffee house in town called Just Us Coffee. So let's compare these two using a two-sided stem and leaf plot, and then we're going to determine the median and the mode and so on and so forth. Okay, so here we go. What do you think about what kind of stems you want? So now I got this going on. Oh, hold on, so here's my stems. On this right, I'm going to put Starbucks data. Okay, and then over here on the left, I'm going to put Just Us Coffee. Alright, so there's kind of like the start. Let's talk bins. The data's going from 8 to 29. Who's going to wait 29 minutes for coffee? I don't know. Somebody who's asleep is who that is going to be, I guess. But, how do you want to do your bins? Okay, I do need a 0 as a bin, but I don't think I want my bins to just be 0, 1, 2. So I think I'm going to split it up into double bins per decade. So I'm going to have 0 to 4, 5 to 8, 10 to 14, 15 to 19, 20 to 24s, and 25s to 30s. Okay. So I'm going to let you take the time, put your data in right now, and we'll check it in a second. Okay. So there's your data. You know what? Let's make a key for this so we know what it says. Here's the key. I'm going to pick a number. Okay. And I could write on the key, I could write for Starbucks and the Just Us Coffee. So, one thing means, no, let me get this for you. Okay, so hold on. So this first one means 10. Now, 10 what? Yeah, 10-minute wait at Just Us Coffee. And then the next one means 12-minute wait at Starbucks. Okay. All right, good. Very good. Now, we could answer things like, where would you like to, where do you think, based on this information, you would go and why? Which one would you choose?
I think I would hit because there's stuff.
Well,
I'd rather support local business.
okay.
I don't like coffee.
Oh, you don't like coffee so much. Okay, all right, it's debatable, so let's talk about it. You do have the highest number. You do have the highest number in the Just Us Coffee, and the lowest numbers in the Starbucks. So, that kind of seems like a no-brainer. However, when you look at the median, which there's 15 numbers, so the 8th one is the median. Then we go 1, 2, 3, 4, 5, 6, 7, 8. So the median for Starbucks is 17, whereas the median for Just Us Coffee ends up being 1, 2, 5, 6, 7, 8, 16. Okay, so I think, it's probably a wash. So there you go. All right, good. Last thing is dot plots. Dot plots. Let's take a look at this initial one here. Okay, there's what a dot plot looks like. So what happens is in this first column, those are all the data values, 5, 6, 7, 8, and 9, all put together, only represented by a dot. Okay, and these, of course, this is the columns of the 10s, 11s, 12s, 13s, and 14s. So right off the bat, what's the disadvantage? Good, you do not know specific numbers, okay? So that's a disadvantage. If specific numbers are important to you, sometimes what's important is just getting the shape of the data. Is it unimodal, bimodal, which is something we'll talk about tomorrow, okay? And I don't really care about the individual pieces. And in this case, and especially if there's a bunch of numbers, this is faster, this is easier. It doesn't tell you the specific numbers, but sometimes you don't need it. Yes. So let's do this. Go ahead.
Why is what we put in here categorizing?
Because when I do this here, I have to do this in categorical or numerical order, okay? Because I need all my 3s, my 4s. So these are quantitative data. Now, I'm not actually going to be averaging any of these, but these are ones where the numerical value of them places them in their location. It's the numerical value that's placing them where they go. These numbers go from the 34 up to 93, so I've just kind of told you that I want those bins. Now, notice that your dots need to all have equal spacing, just like your numbers in a stem and leaf plot all have equal spacing. So, but this is going to be so much easier. Look, I'm going to do this whole row of data pretty quickly. Here's my 40, 66, 43, 82, 52, 58, 77, 52, 50, 48, and 47. So do you see that I gave the rows of dots equal spacing so that when I get to the end, if the column is tallest, then there was the most in that. So it's the area principle is not violated, right? Okay, so I'm not going to put the rest of those in there, but do you see that this is quicker, easier, if all you're interested in is, say, like the shape of the distribution and you don't need to know the particular numbers? No, you do not need to keep it those. Your homework has just 5 problems, 3 of which are multiple choice, 1's a stem and leaf to make, 1's a dot plot to make. So there you go.